In today's lesson, we're going to talk about solving absolute value inequalities, and we're going to answer the question, how are absolute value inequalities solved similarly and different from compound inequalities? So how are they solved similarly and different from compound inequalities? Because they have a lot of things in common in terms of how you solve it. So we're going to start off with a few examples. So to begin, let's start with the example, the absolute value of 3 minus 9a is less than or equal to 16. So what I want to point out is all absolute value inequalities turn into compound inequalities. They turn into compound inequalities. But we do need to make sure that we are able to determine when we use and versus when we use or. So our symbol, the direction of our inequality, tells us everything we need to know. So let's highlight that. This symbol is less than or equal to. When we have the word less than, it turns into an and inequality. So it kind of sounds the same. This is the mnemonic device we're going to use to remember it. Less than is an and. Less than, okay? Anytime we have a less than symbol for our inequality that has absolute value, it will be a and compound, okay? So now we need to rewrite this inequality as a compound inequality for and. Very simple. We're going to take our 3 minus 9a with a less than or equal to 60 and come over here on the other side. That term is going to be greater than or equal to negative 60. Okay? So it's similar to compounds because we made it an and compound, but we know we're using absolute value because we took the positive and also the negative value, which is what you do when you're solving absolute value equations. So what we're going to do now is just go through and solve this compound inequality for A, just like you would if it was a compound inequality without an absolute value. So I like to split mine into the 3 sections. We are trying to isolate this A in the middle, so I'll subtract 3 in all 3 sections. 3's would cancel, we get negative 63 is less than or equal to negative 9a, which is less than or equal to 57. Okay, and at this point we are still solving. We want to go through and divide everything by negative 9 in all 3 sections. Okay, so the 9's in the middle will cancel. We have A, bring down our inequalities. Now, we have to be careful right here because we divide it by a negative. And remember, anytime you divide by a negative number, you do have to change the direction of your inequality. So make sure you remember those rules. They still apply. And negative 63 divided by negative 9 would be positive 7. And over here, we have 57 over negative 9. But let's be highly skilled. Does that reduce? Can we simplify that fraction? I do believe they're both divisible by 3. So we need to change this to negative 19 over 3. All right. So that would be our solution. We can also graph it. I have a video about graphing inequalities that you can watch to show you how to graph that. Let's do another example. We have the absolute value of 3 plus r divided by 7 is less than or equal to 5. Once again, we have a less than inequality, which means this will be a and compound. Because it was less than, we use the and compound inequality rules. Before we do that, we do want to make sure that that absolute value is completely isolated. Remember in example 1, there was nothing with the absolute value on that side of the inequality. By that I mean there's nothing outside of the bars. But in this example, we have a 7 that we're dividing that absolute value by, and so we need to get that moved before we start the process. So let's go ahead and multiply both sides by 7 so that that will cancel. So now we have the absolute value isolated. Absolute value of 3 plus r is less than or equal to 5 times 7 is 35. Now that it's isolated, I can continue on with what I know about the and type of compound inequalities. So I can rewrite this as an and type of problem. It's less than or equal to 35, but it's greater than or equal to negative 35. Okay? It's always the opposite of the number that was given. So now we just go through, solve this as usual, getting that r alone in the inside. So subtract 3 in every section. We get negative 38 less than or equal to r, which is less than or equal to 32. And that would be our solution to that one. Let's move right along to an or problem. How do we know that this one is an or this time? Once again, you look at the inequality symbol. This time it is open to the absolute value, right? It's the alligator mouth is open to the absolute value bars. So this time it is a greater than. And anytime we have a greater than, it is an or problem. Okay, you solve it like a or compound inequality. So our mnemonic device for that, we usually say greater, like turning that into an or, kind of helps you remember that you need to solve it like you would an or compound. Okay, so once again, you want to make sure that your absolute value bars are isolated before you start setting up your compound. And over here, I see there's nothing on the outside of my absolute value bars, so it is isolated already. So now we're ready to write it in two pieces. We take the original, x over 6 greater than or equal to 5, and then or your other piece is going to be absolute value of x over 6. Change the sign, less than or equal to, change it, negative 5. And so you change the sign and you change if it's positive or negative, you do the opposite. So you flip the direction and you change it. So now we want to just solve these. We multiply both sides by 6. We get x is greater than or equal to 30, or x is less than or equal to negative 30 would be our two solutions. So you can simply graph this as normal. I'm going to take a look at another example. Let's do the absolute value. B minus 8 plus 10 is greater than 22. So notice I said it's greater than, so I know I need to do an OR problem. However, before I set this up as a compound OR, I am going to isolate the absolute value because it's not alone this time. That 10 is there. So let's subtract 10 on both sides. Absolute value of B minus 8 is greater than 12. Now we're ready to split it out into the two pieces. So the absolute value B minus 8 greater than 12, or absolute value of B minus 8 less than negative 12. And I've been leaving my absolute value bars on after I turn it into a compound, and really they can fall off at that point. Once you split it into the two pieces, the absolute value bars really shouldn't be there anymore, okay? So this should say B minus 8 greater than 12, or B minus 8 less than negative 12. But we'll continue on to solve. So we're adding 8 on both sides. B is greater than 20, or B is, we add 8 on the other side of that one, B is less than negative 4. And those would be your solutions. So that is a review of absolute value inequalities. When do you use the AND compound and when you use the OR compound? And we have seen how solving absolute value inequalities are very similar to compounds, but you can also see a few differences there. Now, there are some times where we run into special cases, special scenarios where we are not guaranteed just one solution. So let's look at the example in the red box. We have the absolute value of x plus 3 is greater than negative 8. First off, you're probably thinking, since it's greater, this should be an OR problem, and we should go ahead and split it up into the two pieces. And you could do that. You could go through the process and do the scratch work, and everything would be fine. But let's pay attention to what we're actually saying here. We're saying that if you take an absolute value, the answer comes out to be greater than negative 8. Well, let's think about what absolute value means. Absolute value is the distance from 0. That's why we always get a positive number when we find the absolute value, because distance is always positive, right? So negative 5 is 5 spaces away from 0. That's why the absolute value of negative 5 is positive 5. And positive 5 is also 5 spaces from 0. So it's positive 5 as well. So in other words, absolute value always gives you positive. And since it's always positive, it's always going to be greater than a negative number. So when you see this situation, greater than negative, it's always going to be all real numbers. Any real value could be x. Any possible real number could be the value of x. So we really don't need to take the time to solve it, because we can see that any number you can think of that's real will work. Let's look at the other example in the green rectangle. We have 3 times the absolute value of 2x plus 7 plus 7 is less than 4. Looks fine to start with. Let's just work it out. We want to solve this for x. Obviously, we want to get the absolute value isolated first. So that means I don't want anything outside of the bars, nothing. So let's do the reverse order of operations. Let's subtract the 7 first. we end up with a -3 on that side. On this side, 3 times the absolute value of 2x plus 7. Okay. And once again, I do want my absolute value to be isolated. So I want to divide by 3. So the 3's cancel. We end up with the absolute value of 2x plus 7 is less than -1. So let's think about this. Based on what we just talked about, how we know that absolute value is always positive because it's a distance from 0, there is no way it can be less than -1 or less than any negative number for that matter, because if it's less than negative, it has to be negative, right? And it can't be negative. It can't be less than 0. So this is impossible. This is untrue. Anytime you get less than a negative number, you get no solution. Okay, so I would advise you to always isolate your absolute values. Once you isolate it, if you get greater than a negative, it's all real numbers. If you get less than a negative, it's no solution. And you don't have to waste your time trying to solve it. Okay, let's do a few more examples and we will wrap this lesson up. For this example, we have 3 times the absolute value of 2x plus 7 minus 7 is less than -4. So let's get this absolute value isolated. We'll add 7 to both sides. Leaves us with 3 times the absolute value of 2x plus 7, which is less than 3. Okay. Still not all alone. We need to move this 3 here. So we're going to divide by 3 on both sides. 3's cancel. We end up with absolute value of 2x plus 7 is less than 1. Right? So we notice that this is a less than inequality. It's a positive number, so we're fine. It's not a special case. It's less than, though, so it's going to become an and problem. Okay, so I'm going to rewrite this as 2x plus 7 is less than 1, but 2x plus 7 is greater than -1. Right? Because it was an and problem, I could write it all together like this. So I'm still trying to get x alone. It's just that I have 3 sections now. Subtract 7 in all 3 areas. That gives us -8 is less than 2x, which is less than -6. So 1 minus 7 is -6. Now we just need to divide all 3 sections by 2 so that x is alone. 2's cancel. Since we divided by a +2, we don't need to change our sign. Now we'll just have -4 is less than x, which is less than -3. And of course, you can graph your solution. So this has been our lesson on absolute value inequalities, comparing the techniques to solving it, to compound inequalities, when to use and, when to use or. We also discussed special cases, all real numbers, and no solutions, and when to tell when that will be the issue. So hopefully this has been helpful. Don't forget to comment that secret word. Bye.